Okay, we're back. This is video number 3 in this short series. As I was saying, if the word station is good enough for Nikola Tesla, then it's good enough for me. I read several articles and watched many videos on Nikola Tesla, and I have chosen this word for my system perspective, and I'm happy with it. So I have what I call a station. The formal name would be circuit station, all right? The station is made up of an outlet plus protection. I talked about that in previous videos. Or an outlet plus a device, which I call an interface, plus protection. So there's 2 different ways to form that station. Now here's a real simple drawing which shows my concept. Here's the station circuit. That's the circuit that nowadays in contemporary terms would be called a branch circuit. And the branch circuits can be, roughly speaking, general purpose or appliance circuit. And that could be for a 120 volt or a 240 volt appliance. But either way, it's commonly called an alternating current branch circuit. I call it a station circuit. And why do I call it that? Because on that circuit are stations. You can have quite a few, or you can have just one. But it's a circuit station. It's a station that is found in or on a circuit. The contemporary names for this, the traditional names are outlet or box. It could be a fixture box, or they could call it a junction box or a ceiling box. But there's all these different terms that they use to refer to what I call a station. I think I've simplified it a little bit. All right. In my system, there are 6 kinds of stations. Service, or you could call it service entrance station. You could say service entrance. Routing, that's what's commonly called a junction box. That's what they call it now. That's the contemporary term. The switch station, which I showed you. The receptacle station, which I showed you. Then there's the appliance station. It's a station that's dedicated pretty much to only one appliance. Okay? Then there's the unassigned station. That's a station that is power ready. It's energized, but it's not assigned to any appliance. It's not yet dedicated. And I have this little mental helpful hint thing that I use called the in function. And each station pretty much has an in function. Service or service entrance would have the inclusion function. In other words, everything must be included in your service station or you get no power. Nothing happens. You have to hook in to your service station, hook into a breaker somewhere, right? Then routing, that's what's commonly called a junction box. You have intersection, where cables intersect, they're joined together, and they go their proper way. They go where they're supposed to go, but they intersect. The switch station features interruption. You can turn that switch off, and you will deny current and deny power to your appliance. Okay, the receptacle station is pretty simple. You push the plug into the slots, you insert the plug into the receptacle, or you insert the lamp into the fixture. And then there's industry. Why? Because the appliances are great. One of the greatest things ever invented was the clothes washing machine. Tremendous invention, one of the greatest ever. It does a huge amount of work. That's industry. And finally, there's your unassigned station, and that's indeterminate because nothing has been assigned yet. All right? So someone might ask, why does this old guy who makes these goofy videos include the service entrance panel in his selection of stations. Okay? That astute viewer might say, is the service station a station proper? Is it complete in itself, or is it part of a larger system? Now, when I talk about a residential electric service like here at my house, I'm not talking about the meter. We're not including that. It's not necessary. And we're not talking about a first means of disconnect if it's outside and it comes before the meter, as is required by code in some states. Okay, so we're not talking about that meter or a means of disconnect other than the one in your service entrance panel. Okay, so we ask, well, if this old guy considers your circuit a station circuit, which you would call a branch circuit, right? And he says that there's these stations, these circuit stations on that station circuit, all right? If that's how he looks at it and that's how he thinks about it, would the service entrance panel actually be a station proper? So let's do a quick review of what I talked about in my previous videos. In the Greek and Latin languages, circle, cycle, and circuit pretty much mean the same thing. So what we have here, when we look at the big picture to see where the service entrance panel would fit in to the system, we take a look at the big picture, okay? So here we have the generator. The generator makes one revolution, right? And that revolution, theoretically, creates one cycle. See, people call your residential electric service single phase, but that's actually not true. That's a crappy, stupid name. Your service is actually single cycle service, because in that cycle are two phases. I talked about that at length. So anyway, the point is, circle. It's a concept, circle. Your generator, all right, goes around. It creates this theoretical cycle, all right? And you have all these electrons moving, and it creates current, right? And current flows in the circuit. It goes one way, all right? Then it goes the other. And this happens many, many times. It goes super, super fast, all right? So basically, we have kind of a circular kind of essence here going on, kind of an underlying thing, all right? Now, if we go all the way back to the transformer, okay, let's say it's up on the pole, usually where they are, or it could be a ground mounted in a box, but ordinarily they're up on the pole here in Pennsylvania. So you have your transformer. Now, people look up at the transformer and they generally see three conductors coming off the transformer. So they think there's three separate conductors. That's what people think. But that's actually an illusion. All it is really is one long conductor, and it makes a loop. It makes a circle, right? It's only really one. You see, like you'd see in your panel, your black conductor, then you might see your hot red conductor, but it's all part of the same thing. It's just coiled up here. And when those conductors come off your transformer, it creates the illusion of you seeing two separate hots. And then you'll see the neutral. Okay, it's tapped into the center of your coil. I call this a median, actually. You can see that in my videos. But anyway, they have this neutral coming out. So technically speaking, you really only have 1.5 conductors. But the point is, the essence of the system is circular. And if you consider that your system actually starts at the transformer's secondary windings, if you look at it that way, then you see how the service entrance panel can be considered a station the way I look at it in my system. All right? So we looked at the big picture, and we saw that the service station, as I call it, you would call it service entrance panel, could conceivably and nicely fit into my system. But we ask another question. Does that service station meet the station criteria that I outlined in my previous videos? In other words, do we have an outlet, the framework aspect? Do we have a device or interface, which would be the hardware aspect? And do we have protection? The safeguard aspect. All right, do we have that? Well, we look at that service station, right? We look for an outlet, and we see, of course, there's a giant box, giant electrical box. It's called a panel. They call it service entrance panel. So you see clearly that you have a designated, exclusively assigned box, and it's called a panel, right? The things that are attached to the panel and contained within the panel give you the outlet. So the outlet is obvious and clear. Are there any devices or interfaces? Well, you have your main breaker and you have your station circuit breakers. You would call them branch circuit breakers, right? So you have an interface aspect, and that would, excuse me, that would look like this. This is a primitive drawing. You have a transformer and the bus bars in your service entrance panel. And the interface is your main breaker. All right, that's interface number 1. And interface number 2 would be your station circuit breaker, or you would call it your branch circuit breaker. All right, and that's an interface for your bus bars and your station circuit, which you would probably call a branch circuit, okay? So here's your station circuit, and then here's your little stations. But the thing is, you see that essentially you do have two kind of interface actions happening in that one panel or that one station. All right. Now, is there protection? All right. Well, all the protection means in this service entrance panel are resident. That means the means of protection are found inside the outlet. If the means of protection are found outside of the outlet, it's called remote protection. But all these forms are resident. They're in the outlet. So what do we have? We have the main breaker, which provides protection. And I have a surge protector here in my panel, which I'll show you in my next video. So that's the second form. Then there's your grounding system. And of course, there's the cover. So there's 4 means of protection here on my panel. So tomorrow, I'll go around the basement here and I'll show you examples of each of these stations. Now that I've mapped out and shown you why they can logically be included. Okay, I'll show you physical examples of these. All right, so thanks for watching, and we'll see you when I come back.